we visit a basic block. We check if it's the first time, and if it is the first time, we only process the phi functions. So we process each instruction at a time, or statement, and if it's not a phi function and we should only visit the phi functions, then we return. And why can we do it like that? Well, all phi functions are at the beginning of the basic block, except the label, of course, but the phi functions should be before any other instruction. Okay, so to visit a statement or instruction, we can use a switch and see which type of instruction it was. If it was an unconditional branch, then we add an edge from the current vertex to the only successor vertex. Okay, if it's a conditional branch, which edges to add depends on what we know about the operands. So if we know that the branch is taken, then we add the appropriate successor, and if we don't know, then we add both. This can, of course, be used in a similar way for switch instructions. And as an example of a normal instruction, we have the add. So we find the value of the left operand, the value of the right operand, and then the result is what we can determine from the left and the right. So if both are constants, then we can compute the constant result. If any of them is non-constant, the result is non-constant. And if the result here is less than the value of the instruction, and this means less than in the sense of the lattice value, that is unknown, constant, or non-constant. So if we have stepped down, then we add the uses of this variable to the SSA work list and update the value of the instruction. And for phi functions, we start with the, we need to go through all the operands, so we can start with setting the result to unknown, and then for each edge coming into this vertex, which is executable, we check the value and update the result based on the previous value of the result and the value of this operand. Okay, and as for the add instruction, we may update uses of the destination of this instruction.